In this screencast, we are going to talk about density and specific gravity. Density is an interesting measurement for certain substances because a lot of times it's used to characterize a substance or characterize a pure substance. Density is the ratio of mass to volume. So it's a derived unit. And so when we look at this, density a lot of times is represented with a lowercase d, and it just equals the mass divided by the volume, which a lot of times mass is given the symbol m and volume is given the symbol v. When you see things like this is what's called a density column. And you can see we have different liquids that are here on the density column. And what we find is that things with heavier densities or bigger densities are here at the bottom, and then things with smaller densities are here at the top. And the difference in density is the reason that we can have a layered column like this. Now, you probably have already experienced this. If you have ever taken water and squirted Dawn dish soap into the water, you see that the Dawn dish soap settles at the bottom. And that's because they have different densities. Now, a few other notes about density is this is an extensive property as opposed to intensive, because the amount of mass doesn't matter because there is a ratio of mass to volume here. It's used, as I mentioned before, it's used to characterize a substance, right? And there's different units for density. Some common units are grams per milliliter, grams per centimeters cubed, and grams per cc. So remember, 1 milliliter equals a centimeter cubed, which equals a cc. For gases, which we'll talk about gases later, a lot of times it's grams per liter is what you'll see for gases. We're going to do some density examples. Before we get into that, I want you to see some densities of common materials. So this is a chart. Do not memorize this chart. It's just an example of kind of some different densities that we have here. When you look at a chart, you can see here, this is in grams per milliliter. Air, the density of air is very, very small. Gold is, the density of gold is very large. We can see just some other kind of interesting densities here. And so I just wanted you to be able to see what common densities are. So if you get a density that's like 7,000, that maybe your number is off. It's nice to know kind of a reference or where those densities would be. All right, so let's talk about working problems with density. When we work problems with density, it's important to know, of course, that density equals the mass over the volume. What I have found, though, is that students really enjoy the density triangle. This is a helpful way for you to relate the three different values together. So the way we set this up is mass divided by volume equals density. And so if you are moving up and down on this chart, then you are going to divide. Okay, so what that means is if we take the mass and we divide it by the volume, it gives us the density here. But if we also take the mass and divide it by the density, it'll give us the volume here. If you're moving across, you can take the volume times the density and it will give you the mass. Right? And so this is just a helpful tool. If that tool does not help you, you can ignore it. There are multiple ways to solve a problem, but I have found that students do really enjoy that particular tool. So let's look at this. We have a 2 centimeter cube sample of aluminum and it's found to weigh 5.4 grams. Calculate the density in grams per centimeter cubed and grams per milliliter cubed. So when we look at this, we have I like to list the things I have because now we're past conversions where we just have one number. So when we look at this, we say, okay, for context clues, right, I want to pull out all the numbers, okay? And I say we've got a 2 centimeter cubed sample. I know that centimeter cubed, that tells me this is the volume. Those are units that tell me it's the volume. So I can come here and I can say, okay, I know the volume equals 2 centimeters cubed. My next context clue I run into is the mass, which is here, 5.40 grams. And again, we look at the unit to give us a hint that this is the mass. We know that mass has units of grams. So my mass here equals 5.40 grams. And it asks me to calculate the density. And so density here is what we are looking for. Now, I don't love word problems, so I always like to kind of make a list here over on the left-hand side so that I can focus on what's really important. And so I've got the volume and the mass, and I now need to relate the density. And I remember the density formula or the density triangle here, where I can take the mass and divide by the volume, and that will give me the density. And so when I set this up, I say, okay, hey, look, I know the density equals the mass, which is 5.40 grams, divided by the volume, which is 2.00 centimeters cubed. And when I do this math, I get 2.70 grams per centimeter cubed. Now, when we look at this, you may say, hey, I only got 2.7 in my calculator. Where'd that 0 come in? When we look at this value here, right, we have 3 significant figures. We also have 3 significant figures there. And so our final answer here should have 3 significant figures. And so if your calculator only gives you 2, the way to increase the significant figures is to add a 0. And so our significant figures now match the answer. Now, we have checked off part of this problem, right? But you always want to go back and make sure that you've answered every part of a problem. And so we see there's a second part where we also need to give this in grams per milliliter. Because I know 1 centimeter cubed equals 1 milliliter, I also know that 2.70 grams per centimeter cubed would be the same as saying grams per milliliter. So we've answered each part of this problem with these 2 answers here. Let's look at another density calculation. Okay. Calculate the volume in milliliters of a liquid that has a density of 1.20 grams per milliliter and a mass of 5 grams. So when I look at this problem, we're going to go step by step and pull out our context clues. Calculate the volume. Okay, so that's calculate the volume. That's what we're looking for. So I put a big V here and a question mark. And then the next thing I run upon, right? And another important thing is it tells you in milliliters. So I'm going to put a question mark and milliliters here. So that's the next thing I hit. Of a liquid that has a density of 1.2 grams per milliliter. So density is important, so I'm going to write it here. And a mass, so there was the density, and a mass of 5 grams. And so that tells me the mass equals 5 grams. And so I know that density equals mass divided by volume. And I also know my density triangle here is mass divided by volume equals density. And I have, when we look at this, right, I have the mass here and the density here. And so I'm looking for the volume, which is right there. And so the density triangle tells me if I take the mass and divide by the density, that will give me the volume. So I come here and I say, okay, I'm going to take 5 grams. And I am going to divide by 1.20 grams per milliliter. And when I do that, that gives me 4.40 0.17 milliliters. Each of these numbers have 3 significant figures, and this answer also has 3 significant figures. Now, I want to talk to you about the units for just a second. When we look here, this unit is in the denominator of a denominator. And so because milliliters is a denominator of a denominator, it flips back up to be in the numerator. Now, if you don't like using the density triangle, another way that you can do this is by canceling out the units. There are multiple ways to solve a problem. So for example, I could have taken 5 grams here and then said, okay, hey, look, I know I need to cancel out the grams to give me the answer in milliliters. And so that would have been 1.20 grams per milliliter. And you can see your grams cancel here, and you're left with milliliters, which is what you're asked for. And that also gives you 4.17 milliliters. Doesn't matter which way you use the way that makes the most sense to you. Let's do another example. Okay, air has a density of 0.0013 grams per milliliter. What's the mass of a 6-liter sample of air? So I want to list everything that I know, all my context clues. So we've got a density of 0.0013 grams per milliliter. So density equals 0.0013 grams per milliliter, right? And then the next thing is it's asking for mass. So I'm going to come here and I'm going to say, okay, it's asking for mass. And it doesn't give me a unit, but I already know the unit of mass would be grams. And then we've got a 6-liter sample of air. And I know liter is our context clue to tell me that's volume, because that's a unit of volume. Okay. Now, when I look at my density triangle, right, we have mass divided by volume times density, or, of course, density equals, right, mass divided by volume, whichever one you want to use. And so when I'm looking at my density triangle, right, I have the density here and I have the volume here. And so I know that I can multiply these two and that'll give me my mass. Now, there's a problem though, and the problem is that our units aren't the same. So I want to look at that. Let's say you don't catch that, right? So we're going to come here and we're going to take our volume and multiply the density, right? And that should give us our mass. So let's say I don't catch that. Let's say I'm just like, okay, look, I'm going to plug in my volume. That's 6 liters times the density. That's 0.0013 grams per milliliter. That's going to give me the mass, and I know mass needs to be in grams. This is where you should catch yourself. You should always check. Do the units I want to cancel, the liters and the milliliters, do they agree? Are they, then another way to say that is, are they the same, right? And here they're not. So that's where you need to stop and you say, whoa, those are not the same. I need to figure out how to make these the same so that they can cancel out to give me grams. And so that's a really good, if you're working a problem and those units don't cancel, that's a really good time to step back. It's a great double check, right? You can step back. And so this tells me then before I can do that, I need to come here and say, okay, they do not agree. So I need to convert liters to milliliters, and then they will agree. So I come here and I say, okay, I've got 6 liters, and I know that there's 1,000, nope. I know in 1 liter, there's 1,000 milliliters. Notice how I caught myself. I caught myself because I knew those milliliters would not cancel, right? That's a really common thing to do. And so now we come over here and we say, all right, hey, look, that gives me 6,000 milliliters. So now I can go back and say, I'm going to take that volume, 6,000 milliliters, and multiply it by 0.0013 grams per milliliter. And now my milliliters cancel, right? And I'm left with grams, which is what I'm looking for. Now, when you do this, you should get 7.8 grams with two significant figures, because when we go back up here, you always want to go back and look at the numbers that are given. And when we look here, there are two significant figures. And when we look here, there are two significant figures. So you want to make sure your answer has the proper number of significant figures we're multiplying. So two significant figures would be the correct answer. So we've done several density problems. I want to talk to you a little about specific gravity. Values of density are often related to some sort of standard. And the standard a lot of times is water. And so when we talk about specific gravity is the ratio of the density of the object to the density of pure water at 4 degrees Celsius. This is 1 gram per milliliter. Okay, so what that means is that you would take the density of the object in grams per milliliter and divide by the density of water in grams per milliliter, and the units would cancel, so it would end up being unitless, right? But because we're dividing by 1, the value stays the same. So, for example, I'm going to flip back over to that table that we looked at with all the different values. So, for example, if you had gold, right? We know the density of gold equals 19.3 grams per milliliter. If we were to calculate the specific gravity of gold, we would take 19.3 grams per milliliter and divide it by 1 gram per milliliter. And these would cancel, and you would get 19.3 as the specific gravity of gold with no units. Now, so why do we talk about this? Why is this valuable? One of the things that you will see is that this is used in the health industry. So when I go for my yearly checkup and they run all of my numbers, the numbers that I'm given are given a lot of times in specific gravity. So it's used to test urine and blood samples. And so we go over this so that, years from now, when you get blood samples or urine samples and you look and you see, hey, what is the specific gravity? You know that it relates to the density. And so it's something that you'll see kind of out there. It's a real world application. It's something you'll see in the real world. Okay. So we've gone over density and specific gravity. This finishes up chapter 1 for us. If you have any questions, please feel free to email me or stop by my office. I am happy to help.